live streaming. Live streaming. Okay, all of you, I hope you can see the screen, everybody. Okay, all of you. So this class is live now. Everybody, please join the class by using the link. So this will be live class, all of you. Please make it fast. YouTube class. Okay, all of you have joined the class, please. There will be some time lag. Some time lag will be there. No need to worry, all of you, please. Okay. Nothing to worry. We'll just wait for 1 more minute. Everybody should join the class on YouTube. Okay. So this will be a live session, please, all of you. Join the class by using the YouTube link posted in the Telegram group. Everybody should join the class. Till now, we have only 4 participants, my dear students. Everybody should join the class. Only 3 members joined the class. Yes. Within 1 minute, I'm going to start the class, all of you. Have some patience, please, everybody. Within 1 minute, I will start the class. Have some patience, all of you, everybody. Please have some patience. Okay, so all of you here in the class, we have 15 members in the Zoom. Please, 11 members are there. Please join the class in YouTube. Come on, please make it fast, all of you. We shall start the class. Good evening, everyone. You can leave the Zoom and you can go to YouTube. Anyway, you can get the class. This is a perfect live class, please, all of you. Listen to the class, all of you, okay? Okay, so I'm going to start the class. All of you, please check it. Everybody, all of you. Yes. So today we are going to discuss about a very, very important concept, that is work energy principle, all of you. If you have any doubts, all of you, if you have any doubts, you can just raise your hand in the Zoom. Or Zoom lo ganaka lekapothe, you can just chat with me in the YouTube. YouTube lo you can chat with me, all of you. Okay, YouTube lo chat cheyandi, you can just ask any doubts to me, all of you. Nothing to worry about this one. Okay, 1 second. Join the class. YouTube link. He sent in the years. Okay, yes, please. Work energy principle. Okay, yes, so it can be any semester exam, it can be any competitive exam, it can be any, again I'm repeating all of it, can be any semester B.Tech exam, or it can be any competitive exam, all of it. Definitely there will be some questions, definitely there will be some questions from the work energy principle. Okay, all of you. So you will be definitely getting some scoring marks, definitely easy, and we will make it easy for you to score full marks from this principle if you just listen to the class for exactly 35 to 40 minutes. Okay, all of you. Okay, yes, now just see, listen carefully, all of you. I'm taking a body here, I'm taking a body, all of you here. Okay, so on this body I'm applying some force F. On this body I am applying some force F in this direction. Okay, let us assume that because of this force the body is displaced by a value of s meters. By the application of this force, I am assuming that this body is displaced by a distance of some s meters like this. Okay, where I am taking this one as the perfect value is how much, displacement, nothing but s meters I am taking all of it. Okay, so if the initial velocity is equal to 0, I am assuming that because of this force F, velocity has been increased from u to v meters per second. Are you following what I'm trying to say here? Yes. Okay. So ఈ ఫోర్స్ అప్లై చేయడం వల్ల ఏమైందంటే ఇనీషియల్ వెలాసిటీ అంటే రెస్ట్ లో ఉన్న బాడీ కాస్త ఏమైందంటే మూవ్ అవుతూ స్టార్ట్ అయ్యింది. ఓకే, అండ్ బికాస్ ఆఫ్ దట్ ద వెలాసిటీ హ్యాస్ బీన్ ఇంక్రీజ్డ్ ఫ్రమ్ 0 meters per second to v meters per second. Okay, now what happens, all of you, if you have any change in the velocity in a given time period, can I say all of you that your body is getting accelerated or not? Yes, if you have any change in velocity in a given time, the body is said to be accelerated. But tell me all of you, who is giving this acceleration? This acceleration is given by what? The force F. Okay, I'm saying one important point for you. When a force is producing some acceleration, when a force acting on the body is producing some acceleration, that force is generally called as an unbalanced force. ఏ ఫోర్స్ అయితే బాడీ మీద యాక్ట్ చేయడం వల్ల బాడీలో యాక్సలరేషన్ ప్రొడ్యూస్ అయిందో, దిస్ ఫోర్స్ ఇస్ ఆల్వేస్ కాల్డ్ as unbalanced force. చాలా 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 ఇంపార్టెంట్ పాయింట్. హియర్ ఐఎమ్ రైటింగ్ దిస్ యాక్చువల్లీ కాల్డ్ as unbalanced force. So what is the meaning of unbalanced force? Which can accelerate a body. Which can accelerate a body is always called as unbalanced force, I can say. Am I right, all of you, clearly? Yes. Now just see here. Can I say point all of you that more the force you apply, more the acceleration of the body or not? Very simple. This Newton's second law we have. And if you remove the constant of proportionality, I can say F is always equal to what? M into A. Am I right, all of you? Okay. Now just keep this one aside. Now, all of you that acceleration is always equal to what? dv by dt. Right? If we just rearrange this one, we can write this one as dv by ds. Here I am writing multiplied by ds by dt. Can I write it or not? Yes, we can write. We can write definitely. Rearrangement we can say. Okay. Can I say this ds by dt stands for velocity or not? Yes. So finally we can write a is equal to v multiplied by dv by dt. Okay. Sorry, we can write this one as v multiplied by dv by ds is the case. So listen carefully what I am trying to do, in this equation we have acceleration in terms of time t. Acceleration in terms of time t we have, but here we have acceleration in terms of displacement. A in terms of displacement, A in terms of time t. You may have a doubt, sir, why you are converting acceleration in terms of acceleration in terms of displacement. So we are writing acceleration in terms of displacement because I want to derive the work energy principle. Work energy principle will be in terms of displacement velocity. What the point, all of you clear? Now just see what I'm trying to do. You can understand here. So here I'm writing, please. So F is equal to M into A, we know already. Okay. So F is equal to M multiplied by, what is A stands for? We can write this one as V into dV by ds. We just multiply this one, we can write it as F into ds is equal to how much? We can take it as M into V into d. Just see, am I right? Now, integrating on both sides of the equation. All of you, for B.Tech students, I'm saying, for B.Tech first year students, this derivation was asked for number of times. Chala salu derivation adigadu. Meer question paper check cheskunde, I have seen the question papers, all of you. Derive work energy principle antunnayandi. Derive work energy principle ante derive cheyali. 7 marks కి ఇచ్చాడు, 8 marks కి ఇచ్చాడు, చాలా సార్లు ఇచ్చాడు, ఇది డిరైవ్ చేయాలి. ఓకే. సో ఇక్కడ లిమిట్స్ ఏంటండి? 0 to s. ఇక్కడ లిమిట్స్ ఏంటండి? u to v. అంతేనా? Definitely we can say. Okay. If you bring this f as constant, if you are applying for example a constant force, I can bring this f outside. Therefore I am taking this one as f into s minus 0 is equal to m into, okay, can I take this one as definitely v square by 2 or not? Integration. So u to v, initial velocity, final velocity. Therefore I can write this one as f into s is equal to finally half into mv square minus half into mv square. This derivation, again I am saying this derivation is required for first year B.Tech students semester examination. Okay, there is a possibility for this derivation for 7 marks. Very simple అండి, నేను చెప్పిన పాయింట్ మీరు రాసి సరిపోతుంది. ఓకే, మీరు అక్కడ రాయాల్సింది ఏంటి అంటే, ఫస్ట్ ఆఫ్ ఆల్ ఐఎమ్ టేకింగ్ ఏ బాడీ having some mass m, having some initial velocity u. On this body we are applying some unbalanced force. Because of this unbalanced force, the body is getting accelerated. Okay, so whenever a body is getting accelerated, we can write this statement at the Newton's second law. And from the Newton's second law, we can write F is equal to m into a. And I am writing a in terms of v into dv by ds. Here I wrote a is equal to dv by dt. I am writing dv by dt in terms of v dv by ds. I wrote this one clearly, explain this one clearly, all of you. Therefore, substitute this one in this equation. Upon integration, you can get this equation here. Okay, so now tell me, all of you, what this equation says. One second. So now tell me, all of you, what this equation says. This term always represents work done, and this one always represents change in the kinetic energy. Okay, so let me write this statement once again here, all of you. If you listen to this class till end, only for half an hour I am asking, if you just listen to the class for half an hour, definitely you can get some practical points. You can really enjoy the subject of work energy. Now just we are entering into the subject, slowly we are entering. Okay, now just see, I am writing the statement once again, all of you clearly. So f, one second, f multiplied by s is equal to half multiplied by mv square minus half multiplied by mv square. Okay, so this always represents what, work done. This always represents what? The change in the kinetic energy. Therefore, I can say one important point all of you that work done is always equal to what? The change in the kinetic energy. For a body, we can say that. Okay, right. Can you say all of you what is the definition of work done? I'm saying I'm just asking this a question to everyone of you how to answer to me. Very important discussion is going on right now. Tell me all of you how you can define the work done in terms of vectors. You know very well, work done is always equal to dot product of two vectors. One is force vector and one is displacement vector. Am I right, all of you? Check it. Okay. So in terms of vectors, this will be always a dot product. Again, I doubt why it is a dot product. Okay. Dot product will always give a scalar quantity. Dot will always give a scalar quantity. Tell me all of you, your work done is always a scalar quantity or not? It is having only magnitude but no direction. Am I right, all of you? Okay. Can you give an example for the cross product? Yes, we can give. Cross product m bar is always equal to what? R bar cross f bar. What is this one? This is the best example for moment of a force. Why I am writing cross for the moment? Why I am writing dot for the work done? Because moment is a vector. A vector will be always obtained by a cross product. A scalar will be always obtained by dot product. This basic we have to know. Okay. Right now, actually, this is not necessary for us, all of you. I'm discussing about work done only. And just see all of you, if we just remove this dot product, what happens? This will be definitely what f multiplied by s multiplied by cos theta. All the angles I will show, it will take some time. Listen to the class. Okay, fs cos theta. Array, what is this angle theta? Yes, exactly. One second. I have to give you a reply. Okay, so exactly. Now tell me all of you what this theta represents. Theta is always nothing but angle between force and displacement. Force displacement the angle entaithe undo dani theta anta. What's the point of? Therefore, what I can say? Tell me clearly. Now, depending upon this angle theta, work done will always may become positive or negative or zero. If theta is 0, for example, work done will be different. If theta is equal to 90, work done will be different. Theta is equal to 180, work done will be different. Therefore, for different angles of theta, you are getting different values of work done we can have. Now, I'm having one more discussion with you. Just take it clearly. Actually, I'm saying that work done formula is equal to fs cos theta. I'm saying, am I right, all of you? But here, why do we wrote? But here, why do we wrote work done as f into s directly? Anybody, all of you, can you say? ఇక్కడ నేను ఏం రాశాను? వర్క్ డన్ ఏం రాశాను? fs cos theta రాశాను. మరి ఇక్కడ మీరు వర్క్ డన్ ఈజ్ ఈక్వల్ టు f into s ఎందుకు రాశారు? ఎందుకంటే చూడండి, ఇది నేను డిరైవ్ చేసినప్పుడు while deriving this one, what is the angle between force and displacement? Can I say this is the force and this is the displacement or not? This is force displacement. Force ki displacement ki majhilo angle anta? Both are in the same direction. The angle between them is equal to 0. So what is the value of cos 0? Cos 0 is equal to 1. When cos 0 is becoming 1, what is the value of work done finally? F into s. Therefore, can I say point all of you that when force and displacement both are acting in the same direction, when both are acting in the same direction, all of you, what happens? Definitely. Now, what happens? Definitely, work done will be definitely equal to what? F into s is the picture. Okay. So again, I'm repeating. When work done will be equal to f into s, work done will be equal to f into s. We can write directly when both are acting in the same direction. Right, all of you? Now just see here. Now I'm having a simple example for you. Just try to listen this one. Very important discussion we can have now. Okay. Now just see here. I'm having some inclined plane here. I'm having some inclined plane here, all of you. like this. Okay. Now on this inclined plane, I'm having a block. Right, all of you? Right? Okay. Now, let this angle be, for example, some theta. Is the angle we can have. Okay. So I'm just going for the free body diagram. All of you know about very well about free body diagram. So wait. Second thing is what? Normal reaction we have. That is assume the direction of your friction. Okay. So I'm resolving this weight into two number of components. You know very well, one will be W sine and one will be W cos. Okay. So for my previous classes, all of you just subscribe to my channel. For my previous classes, you can see all my recordings. I told about free body diagrams, everything will discuss in detail. Okay, all of you, no need to worry about this one. Okay, so these are actually W. Okay, so this is actually 90. Then this will become definitely how much? 60. Okay, so this will definitely become what you know, W multiplied by sine 30, or we can write this one as cos 60 also we can write. This one we can write as cos 60 also. Okay, or you do one thing, I'm resolving with cos 60. I'm resolving with an angle of 60. For what happens, tell me, this has to become definitely cos 60, and this will become definitely how much? Sin 60. Both are same anyway. Okay, this become normal reaction and this become the friction. Now tell me, all of you, on this body totally how many forces are acting? Normal reaction, friction, W sine, W cos. Totally we have four number of forces, right? Now for all these four number of forces, I want to calculate work done. Simple problem just now. Okay, so this, all of it, this is exclusively for the first year B.Tech students, by using which you can score full marks from the work energy principle concept. Definitely, for sure, I'm saying all of it clearly. There is a picture now. Okay, now tell me, all of you, I'm assuming first of all the displacement direction. Okay, I'm assuming that this body is moving downward. Displacement is acting downward. Tell me, all of you, first of all, one by one we shall see. 1 second. Okay, what is the work done? WD, work done by normal reaction. We shall do first of all for W cos theta. Okay, next, work done by W sin 60. Next one, work done by normal reaction. Next one, work done by friction. We have to go for a problem also now. Okay, are you following all of this? This is the picture. Totally we have 4. Yes. Okay, right. Now tell me, all of you, what is the angle between force and displacement here? Okay, just see here. First of all, let me write this one clearly, all of you. The formula for work done is what you know? F S into cos theta. Theta is the angle between force and displacement. Am I right? Okay. Now tell me, what is the force here? First of all, W into cos 60 is the force. W cos 60 is the force ending. Okay. Next, displacement is what? Tell me. Into S. What is theta? Tell me, all of you, what is the angle between W cos theta and displacement? Can I say both are in same direction or not? When both are in same direction, what I must tell me? This will become definitely what? Cos 0 degrees. It has to become definitely 1. Okay. Therefore, finally, I can say W cos theta into S is the work done. Can I say, all of you, this is nothing but positive work done or not? Yes. What about W sin theta? Can I say that W sin theta is perpendicular to displacement or not? Displacement is along the plane and W sin is normal to the plane. Both are perpendicular. Therefore, I can say all of you that W multiplied by sine 60 degrees into S, okay, into cos 0 is equal to, we can write, sorry, it becomes what? Again, I'm sorry, it becomes what? Definitely 90 degrees, all of you. 90 we can have. Therefore, here the work done will be 0. Perfectly 0. Now, what is work done by normal reaction? Can I say that N is perpendicular to displacement or not? What is the angle between this N and this displacement? 90. What is cos 90? We can take it as work done as 0. Directly we can write. Okay. Now, what about work done by this frictional force? Can you say friction? Yes. Friction is acting opposite to what? Displacement. F is acting opposite to what? Displacement, I can say all of you. Therefore, I can write finally this one as what? Frictional force into S into cos 180. Therefore, this will become definitely minus F into S. Therefore, see, all of you, I'm having a very, very important conclusion for you. You just see the conclusion what I am trying to say. Okay? Just see, observe clearly, all of you. Here, work done is positive. Here, work done is 0, again 0, and here we have work done negative. Therefore, can I say a point, all of you, that work done can be positive, work done can be 0, work done can be negative also. Am I right? Therefore, the very, very important point is, depending upon the angle between force and displacement, work done can be positive or negative or 0. When force and displacement both are acting in the same direction, work done will become positive. When displacement is perpendicular to the force, work done will become 0. When force is acting opposite displacement, work done will become negative, because it is trying to reduce the displacement and one is trying to increase the displacement. All of you, I can say. Are you following what I am trying to say here all of clearly? It's a perfect definition we can write. Okay. So all of you, please come on to YouTube, everybody. So please come on to YouTube. I hope you understand, everybody. Please come on. Please come on to YouTube. Okay. Right. So this is the case, all of you. This one is fine. Now I am going to start a problem. Okay. So this problem is given for semester examination, JNTU Kalikiri, all of you. Very good question I'm just solving. Just see here. Have some patience, okay, all of you. I will take 10 more minutes extra for you. Just wait for the class. Yes. All of you, can you just see the total lettering and wording? Because this is the first class we are conducting live. Till now, we are discussing the classes only in the Zoom. For the first time, we're discussing in the YouTube, all of you. I hope everything is fine and perfect. Right. Thank you, Vijeta. Thank you so much. Right. Now just see here, all of you, this question. Have some patience. Okay, let's see. Yes, a 20 kg block, starting from rest, slides upon a 30 degrees inclined plane under the action of 175 newtons force directed along the inclined plane. Very simple. Draw the figure here. Okay. This is the inclined plane, right? Okay. And this is the block we have. Very good question. Okay. What is the angle we have? Tell me here. 30 is the angle. Is the angle we have. Okay, all of you? Yes. Let me just go for the given data. 1 second. Weight of the block. Actually, mass is given for you how much? 20 kg. So we can write weight of the body as m into g, mass into gravity. So 20 multiplied by 9.81 is the weight of the body. What is the coefficient of friction mu between the contact surface? Nothing but 0.2. I told very briefly about the friction. What is kinetic, what is dynamic, what is static friction, okay, and what is limiting friction, everything I told clearly in my previous class, all of you. So please subscribe to my channel to get the live updates about my class, all of you. In next coming days, I am going to plan a lecture series which will be including the previous question paper solutions. This will be helpful for the first year B.Tech students for the entire country, not only Andhra, not only Telangana, everywhere, any university, any state, any branch of engineering, all of you. So those questions I am going to solve. I am gathering all the questions, all of you. Now you have to stay tuned for the class. So please inform to all the friends, all of you. I will just give the intimation in the channel that is Excel Vidyarthi. So just subscribe to my channel to get the live updates about my classes. Okay, now just see here. We have a force of how much, please? 175 here up the plane. It is given. Okay, so this is the force P I am taking. What is the value of P given for you? 175 is the value. And he was saying, all of you, that we are applying the force along the plane, parallel to the plane. There is a picture. Okay, right. Next, determine the speed of the block. The speed of the block after it slides 4.5 meters. Listen carefully. Initially, this body is at rest. I'm saying the question clearly. This body is at rest. So when the body is at rest, can I say that initial velocity is equal to 0 or not? Okay. Now, in that position, in that condition, I am applying some force 175. And because of this 175 force, the body is sliding upward. The body starts sliding. Okay. So after sliding for 4.5 meters, he was asking what is the final velocity of the body. Are you following all of it clearly? Okay. Body rest lo undandi. Rest lo unna body మీద force apply chesam. Apply cheyadam valla body move avuthu start ayindi. Move oka 4.5 meters varaku move ayindi. 4.5 meters move ayin tarvata what is the velocity was asked. Ante initial velocity is given, displacement is given, final velocity we have to calculate. First of all, you have to go for free body diagram. Nobody can escape from free body diagram, all of you. Those many diagrams I told for you already. You can check all my previous classes. All of you got it? This is the case now. Okay, so now all of you, this becomes N. One second. M, this becomes W. Okay, it is 90 kabatti idine undam 60 annam. Okay, therefore this will definitely become what, you know, cos 60. Inko doubt ఏంటంటే cos 60 place లో sin 30 కూడా రాయొచ్చు. Both will be the same answer. Okay, and here we can write this one as W multiplied by sin 60, or we can write this one as what? Cos 30 also we can write. Same answer we can get, cos 30. Anyway, but no confusion, all of you. If you have any doubts on resolution of the forces, check my previous classes. If you have any doubt on my previous resolution, go for previous classes. What about direction of friction? What is impending motion? Upward. Direction of friction, obviously downward. Friction special kabatti ila vedam. Okay, the body is actually moving upward. Okay, therefore this become the frictional force here. Okay, now tell me, all of you, which principle you will apply? ఇంకేం అప్లై చేస్తాం? ఇప్పుడు మనం చేసింది ఏంటి? వర్క్ ఎనర్జీ ప్రిన్సిపల్. ఒక పాయింట్ గుర్తుపెట్టుకోండి. ఎగ్జామినేషన్ లో డిస్ప్లేస్మెంట్ ఉండి వెలాసిటీ కనుక అడిగితే we have to go for definitely work energy principle. ఎందుకని చూద్దాం. let us see all of you. Can I say that force into displacement is equal to, we can take it as half into mv square minus we can take it as half into mv square. అంతేనా? అయితే ఒక చిన్న పాయింట్ చెప్తానండి. this is actually called as what, you know, net resultant force. నెట్ ఫోర్స్ అంటాం. ఒక్క ఫోర్సే కదా నెట్ ఫోర్స్. ఇప్పుడు ఎన్ని ఫోర్స్ ఉన్నాయండి ఇక్కడ బాడీ మీద? ఇదేంటి చెప్పండి, ఎన్ని ఫోర్స్ ఉన్నాయి బాడీ మీద? 1 2 3 4 5 ఫోర్స్ ఉన్నాయి. ఈ 5 ఫోర్స్ వర్డన్ రాయాలి. ఈ 5 ఫోర్స్ వర్క్ డన్ రాయాలి. ఓకే, చెప్పేసి అలా జాగ్రత్త వినండి. ఓకే, సో all of you please tell me, first of all the point is what, this is actually called as net work done or total work done, ఏదన్నా ఒకటి. ఓకేనండి, what is the work done by P? First of all, what is displacement? Tell me, direction displacement is upward. ఏరా అంతేనా? ఇప్పుడు చెప్పండి all of you, force and displacement both are in same direction or not? Same అంటే ఏం చేద్దామండి, it becomes positive. ఇప్పుడే చెప్పాను క్లియర్లీ. Am I right, all of you? If force and if work, for example, just see, if force and displacement both are in same direction, what will become positive? Work done will become positive. Now tell me, all of you, what is work done by friction? F is acting opposite to displacement. Kabatti I can just say work done by the friction is what? Minus F into S plus what is work done by W cos 60? Can I say W cos is acting opposite displacement or not? Therefore, I can say definitely minus W cos 60 multiplied by S. Idantena plus. Aite, what about the case of normal reaction? Can I say that normal reaction is perpendicular to displacement or not? Kabatti ikkada emo finally emayindante work done by N is 0. In the same way, work done by this one is also becoming 0. Endukani? W sin 60 is perpendicular to displacement. Okay, perpendicular displacement. Angle between force and displacement is 90. Therefore, work done by W sin 60 will be 0. Are you following all of it clearly? Yes, pulling force or pushing force. Yes, somebody is asking, Kushi is asking some doubt, and so I'll just see here. The doubt is what, very good doubt. Sir, how are we going to know if it's a pulling force or pushing force? Please read the question carefully, what he was saying. Okay, a 20 kg block starting from rest slides up means what? How the body can move upward by a pulling force only. This is possible only because of pulling force. Am I right, all of you? This is possible only because of a pulling force acting away from the body, I can say. Therefore, this is a direction. Am I right, Kushi? Hope you understand, Kushi. Yes, this will be definitely given for you in the exam. No need to worry at all. Okay, I hope you understand, Kushi. Right, now just see here. Okay, this one is clear. Now just tell me, work done by normal reaction is 0. At the same time, work done by W sin is also 0. Is equal. These are the total work done. This mottam total work done. Total work done is equal to change in the kinetic energy. This is total work done. Very simple ending. On this body, how many forces we have? 5 are there. For all the 5, we should write work done. If we have only one force, write work done for only one force. I am having 10 forces, write the work done for all the 10 forces here. Are you following what I am trying to say? Okay, now therefore I can say is equal to I am writing here, 1 second. So half mv square minus half mv square. It is given clearly that body starts from rest. So when the body starts from rest, what is the initial velocity? U is equal to 0. Now you can just see in the problem, what is the requirement? And displacement what ichchadu, we have to calculate velocity. Therefore, what we will do? Very simple. S is known. Can you bring out the value of velocity or not? Yes, definitely we can bring out the value of velocity. Mass is given, velocity we have to calculate. And one more thing, all of you, this F stands for what? Frictional, kinetic friction, nothing but mu k into n. Mu k into n. Okay, but what is the value of n? Very simple, and n I can take it as W multiplied by sin 60, or also called as W multiplied by cos 60. Then చూడండి ఒకసారి, నార్మల్ రియాక్షన్ అంటే ఏంటి? కొంతమంది ఏం రాస్తారంటే n is equal W రాస్తారు. Biggest mistake. See here, actually this block is resting on the inclined plane. When a block is resting on the inclined plane, normal reaction can never be equal to total weight. N and W equal above. N will be equal to component of the weight. Okay, N will be equal to component of the weight when this body is resting on the inclined surface. Are you following all of you? There is a picture we can see. Okay, now from this problem, can you bring out the value of velocity or not? You check all my previous classes about free body diagrams, resolutions, and everything. Then you can understand what we are doing, all of you. Are you following what I am trying to say here? Yes, yes, perfect. Okay, yes. Now all of you just see here. Here, all of you, what is second question? Only I will leave you in 2 minutes. Okay. Second question, what you were saying, determine the distance traveled by the block when its speed becomes 4.5. He was asking reverse. Yes, see here, I'll explain clearly. Drawing a line. Okay. So I'm just going for the second bit, all of you. Okay. So in the second bit, speed is given. He was asking displacement traveled by the body. S value is equal to how much? Speed is equal to how much? 4.5 meters per second. Can I say body's transformation rest or not? Very simple. What you will do? Again, the same thing we should write. Net force multiplied by displacement is equal to how much? Half mv square minus, we can take it as half into mu square. That's it, all of you. Okay. Therefore, very simple. This step is entirely same. The same step you can write here, all of you. The same step you can write here, all of you. Here you can write. Let me write this one. So applied force into displacement, both are in same direction. Friction is acting opposite, all of you. Okay. Next, W cos 60 is doing negative work, all of you. Negative work, all of you. Decrease into S is equal to, we can take it as, remaining two are doing zero work. Normal reaction W sine are doing zero work. So it becomes what finally? Half into mv square minus, we can take it as half multiplied by mv square. Can I say, all of you, that initially the body is transformed rest or not? Okay. So in the problem, actually final velocity is given. What is the final velocity? 4.5. Substitute 4.5 here. Mass of the body is given for you. Okay. Then you can determine the value of S. Again, I am saying this is F suffix K and F suffix K is equal to how much? Mu suffix K into N. Okay. Therefore, I can say finally mu suffix K into W multiplied. What is the value of N? Just now I told. N is how much? Yes. W sine 60. మీ ఇష్టం ఏదైనా రాయొచ్చు. W sine 60. There is a picture. Okay. So are you following all of? I hope you are following everything. Therefore, this is the work energy principle, all of you. Next coming classes, I will be definitely discussing about the D'Alembert's principle and all those things, all of you. Okay, right? I hope everything is fine, all of you. So please all of you give comments in the session, for the session. Okay. Please give the feedback. Okay, all of you. I'm going to start a lecture series for you soon, everybody. I'm going to start the lecture series for everybody, all of you, which will be having a previous question paper problems from semester examination, all of you. If you follow Excel Vidyarthi in 2 subjects, engineering mechanics and engineering drawing, in these 2 number of subjects, you can score full marks. We are challenging for that. Okay, all of you. Any university, any branch, any autonomous college, any private college, or any deemed university, any IIT, any NIT, and any IIT, IISc Bangalore, it can be anyone. You can follow Excel Vidyardhi. You can score full marks definitely from the class. Okay, all of you. Yes. Welcome, welcome Niharika, welcome Teja. Thanks for joining the session. Please, everybody, all of you, please, everybody, just give the comments and then you can leave the classroom. So please inform to your friends and tell them to join the Telegram group for getting the live updates about the classes. Okay, all of you. Thanks for joining the class. Okay. So good night. We shall meet in the next class, all of you. No need to worry. So everybody, if you have any doubts, you can just ping us in the Telegram groups, all of you. We are definitely waiting for your questions and answers. Please give the feedback before leaving the class. Okay, all of you. So thank you. Good night.